Girls, today we're going to do Unit 5, Module 1, Session 5, Circumference and the Great Knight of Angleland. So today I'm going to share a read aloud with you called Circumference and the Great Knight of Angleland. We will discuss circles and identify the radius, diameter, and circumference of a circle. We will describe, analyze, compare, and classify circles, radii, diameters, and circumferences with partners. However, you won't be working with a partner unless you have someone at home that you can work with. Okay, so for circumference and the Great Knight of Angleland, remember what we learned about yesterday or the other day, that zero angles measure simply zero. They basically look something like this, if you remember. So it's kind of like two rays almost on top of each other. An acute angle is less than 90 degrees. But it's more than zero, right? A right angle is exactly 90 degrees. An obtuse angle is more than 90, but it's less than 180 degrees. And a straight angle is exactly 180 degrees. All right, so now let's talk about a circle. A circle is a round, plane figure whose boundary, the circumference, consists of points equidistant from a fixed point, known as the center. A circle is round. It doesn't have any straight sides. It doesn't have any sides at all. It's curved all the way around, so it doesn't have any corners either. It is simply a circle. So if I were to draw a circle, which I don't think I can actually, I don't know. Well, not really. There we go, we have a circle. So that would be a circle. And when it said equidistant from the center, that simply means that you have a central point. And on that central point, everything coming out from that central point would be equal. So this black line would be the same length as this red line across it, right? And this blue line would be the same length as this green line and things like that and so far, okay? So that's what that means about being equidistant from each other. Okay, so this story is called Circumference and the Great Knight of Angleland. And I apologize, the story is in my classroom, so I don't have it with me. So I'm going to have to do it this way. All right, so bear with me. But Circumference and the Great Knight of Angleland. More than anything, Radius wanted to be a knight. Every day he practiced riding, sword fighting, and archery. His teacher was the brave old Sir Degrees. One day, Radius's parents, Circumference and Lady Di of Amateur, came to watch his lessons. "Show us what you have learned," they said. In the riding ring, Radius mounted his horse, and Sir Degrees gave directions. "Knightly ride, angle, trot," shouted Sir Degrees. Radius rode his horse at a trot to the center of the ring and made an exact right turn. It formed a perfect corner. So the characters are Radius, Sir Degrees, Circumference, and Lady Di of Amateur. "Now double the right angle to make a straight angle," called out Sir Degrees. Radius rode at a full gallop straight across the ring. He came to an abrupt stop right in front of his parents. "Wonderful!" they exclaimed. "You have learned so much." At supper, Sir Degrees said, "Radius is the best squire I have ever taught. He is ready to go on a quest." "He is not old enough," said Circumference, looking worried. Lady Di smiled. "You were the same age, dear, when you went on your first quest." Radius sat up straighter. "I am ready, Father," he said. "Please let me go." Circumference slowly looked at him, each of them, and finally he smiled and nodded. "Hurrah!" said Radius. "I will make you proud. But how shall I find someone in need of help?" "Our neighbor King Lel has disappeared," Sir Degrees answered. "Many have set out to find him, but none has ever returned." "I will search until I succeed," promised Radius. Radius bid them farewell and set off. "I am on a quest," he exclaimed gleefully. Radius rode for many days through the countryside, and one day he came upon a tiny village where all the cottages had rooftops pointed in steep angles. What a quaint little town, thought Radius. Mother would call it cute. He asked a villager about King Lel. His castle lies beyond the mountains of Obtuse, said the villager, pointing to the east. But take heed, there are tales of strange creatures and dangerous labyrinths. No one traveling there has ever returned. I hope to be first, said Radius. Farewell and thank you. Up and down through the mountains of Obtuse, Radius rode eastward. We can hear many math terms in this story. Finally, Radius came upon a walled castle surrounded by a watery moat. He rode cautiously onto the drawbridge. It creaked and groaned every step. As he neared the middle of the drawbridge, it began to crumble. Quickly, Radius urged his horse across. Just as they reached the other side, the old drawbridge collapsed into the water with a tremendous splash. That was close, Radius exclaimed. He rode through the high gates of the castle. In the courtyard, Radius saw a parchment hanging on a door. He took the parchment and read the faded writing. Warning, strange friend or foe. Dangers wait as forth you go. You must make a nightly ride, finding next big straight and slight. One wrong turn means loss to all. In a writhing, screaming fall. Find the right to reach the king, or you will feel the dragon's sting. The brothers Zig and Zag. What can this mean, thought Radius, clutching his medallion for courage. He rode through the doorway into a circular chamber. The middle of the stone floor, Radius could see a carved circle with a line across the center. All around him, arches led to different rooms. Which way should I go? He wondered aloud. He read from the parchment. You must make a nightly ride, Sir Degrees, and I practiced many right-angle turns. Just then, something flapped out of the shadows and bumped his arm. Ooh, grunted Radius, as his medallion went flying. The medallion rolled away and came to a stop on the carved stone circle. Radius noticed that the number 90 pointed directly toward one of the arches. Starting at 0 on my medallion, if I go to the center and then to the number 90, that forms a right angle. That's the nightly right, he cried. Radius swung himself back onto his horse and rode through the arch. That was a nightly right, or 90 on the medallion. The way was dark and damp. Around him unseen things settled in the corners, and by the light of the flickering candle, Radius read the parchment again, finding next straight or slight. What is big, he wondered. Could it be something even larger than the nightly right angle? He thought for a moment. The mountains of Obtuse were shaped like big angles, he remembered. As Radius looked around for a way out, spiderwebs caught him in his hair and tickling legs brushed against his face. Ahead, Radius saw several hallways. Each had a circle carved in front of it. If I hold the medallion over a circle, then the number measures the angle to the hallway, he said. The angle of the first hallway measured only 55 on the medallion. As Radius measured the angle of each hallway, he found only one that was bigger than the right angle. One angle measured 120 on the medallion. Radius entered the hallway, but it ended at a curving stairway. Radius dismounted and told his horse to wait. Stairs are no place for you, he said. Stay right here. I'll come back as soon as I can. The stairway down was narrow and steep. I must be under the castle by now, Radius thought. He noticed that the farther down he went, the hotter it was. The stairs came to an end in a fiery pit where huge flames leaped up in the angry, snapping jaws. 2 bridges spanned the inferno. They both started from the same spot, but they crossed the fire pit at different angles. After big, the parchment reads straight, Radius remembered. That's 120 or 50 on my medallion. 180 on my medallion. You can't get an angle any straighter than that. He took a deep breath and ran across the bridge that went straight over the roaring fire. On the other side, Radius heaved a sigh of relief. He opened a heavy door and entered a dark tunnel. The door changed, shut behind him. Raspy snuffling came from deep in the darkness. 4 glowing eyes appeared and began moving slowly toward him. Clutching his medallion, Radius hurtled down the tunnel. As he passed the eyes, he brushed against scales that felt like cold chain mail. Radius ran blindly and stumbling as the floor started to slope upward behind him. Heavy thumps echoed in the darkness. The tunnel ended, and other tunnels shut off at different angles. In front of each was a carved circle glowing with its own light. The parchment says a slight angle, Radius mumbled, like the rooftops on the cute little village I passed through. A cute little angle is what I need, something that is less than 90 on the medallion. The smallest angle measured 40. So he turned there. The thumps grew louder. Something snuffled and sniffed as if hunting for him. Radius ran through the darkness. Next will be the right to reach the king. Another knightly right angle of 90. At least the last angle will be easy, he gasped. He was wrong. In the dim light, he came across 4 corridors, which all seemed to be right angles. Fingers fumbling, he measured quickly with the medallion. 90, 90, 90, and 90 again. Slow down, Radius told himself. The measure once more. He carefully lined up the medallion and read the numbers. The first angle was 93. Too big, he said. The next angle was 85. Too small, he muttered. The third one was 89. Almost right, he said. Then there was a great whooshing sound, and thick smoke filled the tunnel. Radius was caught inside a dark cloud, coughing and sputtering. He felt his way along to the remaining corridor. I hope this is the one, he whispered. Thump, thump, thump. Something was lurching toward him. He stumbled. Suddenly, Radius ran into a wall of stone. He was trapped. The thumping grew louder. Whatever it was big, and it was right behind him. Radius turned around and stood with his back to the wall. His arm bumped into a latch, a handle. He pushed with all of his strength, and a door swung open. Brilliant sunshine met his eyes. Welcome, a voice bellowed. Who might you be? Radius squinted in the brightness. I am Radius, son of Circumference and Lady Di of Ameter, and squire of Sir Degrees. I am searching for King Lel. It seems that you have found him, chuckled the king, but how did you do it? Radius bowed. My medallion helped me figure out which paths to take. Knowledge gave me the courage to keep going, he exclaimed. But there were frightful things in there. A whimpering came from behind the door, and King Lel opened it wider. Radius jumped back. Dragons, he gulped. A pair of them. They are my loyal pets, the Lel dragons, exclaimed the king. He scratched their heads. The poor beasts and I were trapped in the maze by the evil cousins Zig and Zag, but we are free now that you have found the way through the labyrinth. Young squire, he continued, anyone brave enough and smart enough to figure out that maze deserves his knighthood. With Radius's medallion, they easily found their way back through the maze. To celebrate King Lel's freedom, invitations were sent to all the neighboring knights and ladies. Circumference, Lady Di of Ameter, and even Sir Degrees came. Radius and King Lel went to the moat to greet each other and their guests. When King Lel whistled and called out, Pair of Lels! The 2 dragons stretched across the moat, side by side. They became a living drawbridge for the guests to cross. Everyone asked Radius how he found his way through the maze. I discovered the secret of the medallion, Radius said. The numbers divide a circle into 360 parts. I can use those parts to measure any angle. I call the parts of a circle degrees in honor of my teacher, Sir Degrees. Radius drew a picture of his medallion and took an arrow from his quiver. Let's say this arrow points to a hallway. The number shows how many degrees are in the angle. A right angle measures 90 degrees. A straight line measures 180 degrees. I call angles bigger than 90 degrees obtuse, after the mountains of Obtuse. Angles smaller than 90 I call acute. They look like the roofs in the small village I traveled through. King Lel told Radius to kneel. For your bravery and intelligence, I knight you, Sir Radius, the king proclaimed. From this day forth, let this kingdom be known as Angleland. Banners will fly on every castle tower. They shall show knightly right angles of 90 degrees, small, acute angles, large, obtuse angles, and straight 90 angles of 180 degrees. Rise now, great knight of Angleland. The crowd cheered, and Radius rose to greet them. Angleland was the only kingdom to have a castle with a living drawbridge. The cry, Pair of Lels, brought the 2 dragons over the moat, and they became so famous that today parallel means any straight line side by side, the same distance apart, like the Lel dragons. Angleland is still there on very old maps, but today we call it England. All right, so if you look really carefully right here, when he was talking about the medallion that helped him, he was talking about this specific tool that we have actually talked about in Number Corner before, all right? Okay. So we're going to come back to what that that tool is in just a little bit, but I want to show you this. So if we had our number cards in the classroom, I would show you that this would be the number card that I would put up for a circle. And you can see that there are 3 different sized circles here. A circle is a 2-dimensional flat shape made by drawing a curve that is always the same distance from a point called the center. So like I was showing you earlier, the same distance from a point. So from the center out is one distance, but from the center out the other direction will be the exact same distance from that central point. So they're always equidistant no matter which direction you're coming at from the circle. So even if I go this way, they would be the same distance. Whoopsies, sorry. And even if I go this way through the center, this side and this side would be the same distance. And even if I went this way through the center, they're all the same length, if you notice, from the center. And that would be the same with this circle and with this circle. Okay, so think about this shape. Does it meet the same characteristics as a circle? Well, if I were to just stick a point in the center of it, well, it's more egg-shaped, an oval, also known as an ellipse. However, it doesn't have any straight sides or corners. It's curved all the way around, so it's not a circle. It's almost like a circle that has been squished, okay? And this one's called an oval or an ellipse. But what you notice about this one is that if I were to go from here to here and from here to here, these would be the same distance, right? But if I were to go from here to here and then here to here, these would not be the same distance. Therefore, it is not a circle because all of them have to be the same distance and equidistant from the center in order to be considered a circle. So think about these terms: radius, diameter, center, and circumference. All right, well, I've actually already shown you the radius, and you may already know, but the radius of a circle is when I go from the center of the circle out in a straight line to the edge. This is considered a radius, okay? And I can actually measure the radius from any point on the circle as long as I'm touching the center. It's always going to be the same distance, okay? Now, when you think about diameter, I'm going to do diameter in a different color. Diameter would be if I went all the way across the circle and I did the radius, but then I kept going. The diameter would be the distance all the way across the circle. Now, the diameter, just like the radius, would be the same distance whether I went horizontal or vertical or on an angle. It doesn't matter because the diameter is always going to be the same length no matter where you put it on the circle, okay? Now, when you think about the center of the circle, that's pretty easy, okay? That, my friends, is the center, okay? Some other terms for center might also be known as the focus. So I'm just going to go ahead and put that word in parentheses there. Center can also be known as the focus. And then I'm going to go ahead and pick yellow, and I'm going to call yellow the circumference. Circumference is the distance around a circle, kind of like the perimeter of the circle, if you will. Okay, so the circumference I'm going to do in yellow. I know I'm not doing a perfect job here, but this would be the circumference of the circle. Okay, so those would be those terms. I did the radius in blue. I did a diameter in green. The center I did in red. And the circumference I did in yellow, just so you can kind of see the difference in all of those, okay? All right, so thinking about circles, student book pages 173 and 174. When you look at these circles, what do you notice in the picture in the top left? Now I want you to look at the picture in the top left up here, okay? Just think about them for a little bit. Just want you to take a look at them. And then what do you notice about the shapes on the top right in this picture up here? I'm not going to complete this page right here just because there's not a lot of room. And I've done that to you guys before, and I'm not going to do it this time. So just think about what you notice about the picture on the left and what you notice about the shapes on the top right. What makes them similar, what makes them different, those kinds of things, okay? All right, and then go ahead and open up your student book to page 173. We're going to do that in a little bit. All right, so thinking about circles and protractors, I am so sad right now that we do not have our classroom to have a protractor. Now, you may be lucky enough to have a protractor at home, and many of you may not be lucky enough. To be honest with you, I don't have a protractor at home. So I, just like you, have to rely on what I have in front of me, okay? All right, so So this is called a protractor, this right here. And in the story that I read you, this is kind of his medallion that he was talking about. A protractor is a tool for measuring angles. And we have used these before in Number Corner, okay? So it's like a half circle with a lot of numbers on it, okay? 90 is at the top, so you'll see 90 at the top. It has 2 rows of numbers on the curves, also numbers on the bottom. So you'll see big numbers on the top, and then on this side, you'll see big numbers on the bottom. I like to call those big numbers obtuse numbers. And we know that with angles, an angle can face this way, but an angle can also face that way, right? Okay, we also have little numbers. Now, if you look really carefully, on the bottom, you'll see little numbers, but on the top over here, you'll see little numbers, because an acute angle can face this way, and it can also face that way. So depending on how I'm measuring my angle, I'm going to use the acute numbers or the obtuse numbers. I just need to add an E to the end of the word obtuse. Sorry about that. Okay. All right, 90 is at the top. It has 2 rows of numbers. It's for measuring angles. It's like a ruler for angles. And it's like the top half of the radius is used in the story, except that it was gold, right? Now, what do each of these lines mean? All right, so think about how big 1 degree angle would measure. Now, I'm going to go ahead and just pretend here. So let's say I have an angle. Do you see this dot right here that I'm making green? That's where the vertex is. So I'm going to draw a vertex on each of these angles that I drew. And if I'm measuring an angle, I want to put that vertex right there, okay? Now, if my angle, let's say I was measuring this angle for a second. I would want the one ray to be even with that. And then the other ray might reach out like that. So I know that might not be exact, but if you can see this very carefully, it's on the 40 and it's on the 140. Now, when I look at this angle, I can see that it is an obtuse angle, right? So it's not going to be the 40. That would be a 140-degree angle. So make sure that when you're measuring angles, you're looking at the proper number. First, you want to identify the type of angle, and then you want to make sure that you know which number you're looking at. Obtuse, obviously, would be those numbers that are larger than 90, and acute would be those numbers that are smaller than 90. All right? Okay. So open up to Student Book, page 173, and let's go ahead and complete this page together, okay? All right, so thinking about circles, page 1 of 2. We've got pictures of circles, and we've got things that are not circles on this piece of paper here, okay? So study the diagram above. Circle the circles in the row of shapes below. All right, well, this is a circle, and this is a circle, and this is a circle. All of these other things, and I'm just going to X them out in red. This is not a circle. It's like part of a circle, but missing a piece. This is also not a circle. It's part of a circle, but missing a piece. This is not a circle because it's not closed. A circle has to be a closed shape. This right here looks like the piece that this guy over here was missing, and this is just a little curve. All right, so we have 3 circles. Now, how do you know that the shapes that you circled are circles? Well, our responses could vary a little bit, but what we really want to say is that the distance from the center I should say 2, sorry. Let me go ahead and erase that. The distance from the center to any point on the circumference is equal. Meaning that anywhere I were to look at this circle from the center, it's going to be equal, right? Okay, draw 2 examples of circles, all right? Well, I'm going to draw these over here because I have more room over here. All right, well, there's a circle, and there's a circle. All right, so I'm just going to draw an arrow. Draw 2 examples of shapes that are not circles. I'm going to draw these in red because I crossed them out in red before. And again, there could be many different responses for this. A C, part of a circle, but it's not complete. This is definitely not a circle. That is a triangle, okay? This is not a circle, so there you go. I drew 3, and I was only supposed to draw 2. And then, how would you define circles? How would you define circles? A circle is a 2D, which means flat shape that is perfectly round all the way around. You may have a different answer, but there you go. Okay, so there's that page. Now we're going to look at student book page 174. All right, on student book page 174, we're still thinking about circles. It says use the circle for A through C. Draw and label 2 examples of radius on the circle below. All right, well, I'm going to use blue for radius, and I'm going to draw 2 examples of radius. Here's an example of radius. And here's an example of radius. Okay, so I have done A. I'm going to switch colors here. Draw and label 2 examples of diameter on the circle below. All right, here we go. Diameter, there's one example of diameter. And there's another example of diameter. As long as it goes all the way across, it's straight. I know mine is not perfectly straight. I apologize. And then draw and label an arrow pointing to the circumference of the circle. All right, well, the circumference of the circle Sorry, my kids are being very loud. This is the circumference. Okay. Now, for number 3, it says, draw 3 more straight lines to connect the 4 points on the circumference of the circle below. The first 2 points have been connected for you. Connect the rest of the points in the same manner. These points are all spaced equally around the circumference. Do not connect any points to the center. Okay. And then it says, we're going to answer the questions after that. I'm going to go ahead and use black here. I'm going to connect, connect, and connect. Now I'm going to look at A. What shape did you just draw inside the circle? Well, I just drew a square. Okay. Use labeled sketches, numbers, or words to convince someone else that you have identified the shape correctly. Well, I know that this is a square because it has 4 angles. It has 4 equal sides. And all the angles are 90-degree angles. Okay, so that's how I know that it's a square, okay? Perfect. Okay, you, my friends, are going to complete page 175 on your own. Now, the only thing is, it says that we need to use a ruler to measure the sides of the quadrilateral. A quadrilateral is a 4-sided figure. Now, if you don't have a ruler, I'm going to go ahead and just fill in the measurements for you, and then you're going to go ahead and figure out the rest, okay? So, if you don't have a ruler, I'm just going to fill these in. This is 7 centimeters. This is 6 centimeters. 7 centimeters. 6 centimeters, okay? Down here, we have 7 centimeters. This is 5 centimeters. This is 7 centimeters as well. And this is also 5 centimeters. So you are going to fill in the rest of those and the bottom, okay? And then the last thing that I want you to do is I want you to watch the Brain Pop video on circles. So here's the information for the Brain Pop. These are just 2 of the pictures from the video, okay? So don't feel like they're 2 different videos. If you are not sure of the username, it's PD Student, and the password is student. And please watch the video. It's really helpful when it comes to understanding circles, okay? And that is your lesson for today, boys and girls. Great job.